Hello. For the last couple of days I had a problems with my keyboard, so now probably I will have to record my voice. So better get used to it. I don't know if you will like it or not, but I will have to record myself and listen to my own voice, what I don't like too much, to be honest. I will begin with a minor geomagnetic storm which took place couple hours ago. It wasn't too strong. From what I'm looking, the overall power got only 33.6 gigawatts on the northern hemisphere. It was a little bit stronger on the southern pole, but I was talking many times before that the southern hemisphere is now affected much stronger than the northern one. This is probably the cause of the latest geomagnetic storm. As you can see, since last couple hours, the density and velocity is elevated. If I would have to guess, I would say that this is a CME. On the other hand, there is nothing on the low energy proton flux graph from ACE. The number of protons is dropping down, besides this one spike which took place around 4 UTC. Besides this spike, the number of particles is dropping down. Strange. It looks that even if there is not too much protons in the incoming wave of density in the solar wind, we can see a clear increase of electrons, which is without any doubts connected with the incoming wave. This is strange because CMEs are mostly connected with protons and electrons, so it's quite strange that here we can see only the electrons coming with the density wave. Probably the protons were discharged by the low energy field before they arrived at Earth. This is really strange. It looks that the latest CME wave affected only the stations which are monitoring the geomagnetic field, which are placed further from the northern pole. The disturbances were quite strong. The range rose to 200 minus 200 nanoteslas. But there are no doubts that the incoming wave affected our geomagnetic field, and it did it in a strange way, because as I said before many times, mostly the geomagnetic storms are much stronger, closer to the magnetic poles. And here we can see clearly that the storm was recorded at some distance from the magnetic pole. I don't know what's happening on the SWFM page, but the last image was made at 9:43 UTC in the evening. And since that time this page doesn't work, it's not updating the images. I don't know what's happened, but this page doesn't work anymore. I don't know what caused those problems, but as you can see here, the connection of the flux tube is still clearly visible on the current drinks monitors. But this is probably not the cause. I don't know what is the cause, to be honest. Another way to look at the SWFM data. Here is the page which allows to run in the simulation according to the latest ACE data, but as you can see here, still the latest time is 9:30 UTC, a day before. But on the last image, which is visible here, we can see that the open field lines of magnetosphere are open to the solar wind from the south. This is not normal. Let me show you like this. If this image is correct, then the closed field lines, which are connected with the current rings and the radiation belts, like here, are influenced straight by the solar wind, which can get there from the south, like here. I'm not sure if this image is correct, but if it is, then it means a strong magnetic disturbances taking place in the magnetosphere right now. As you can see here, field lines are directed towards the sun, what is for sure not normal, as normally the field lines, the open field lines are directed outwards from the sun, as they are shaped by the solar wind. It looks that we were hit by something what looks like a frontal density wave of a coronal hole stream. Here you can see that the density is elevated from here to here, and then density rapidly drops while this velocity is rising. It is quite strange because coronal hole streams are mostly rather hot, and here we can see that the temperature is dropping. Anyway, you can see that the impact of the density wave made a clear geomagnetic storm. Here we can see how the ground magnetometers responded to the impact. On the Canadian grass, we can see that the range was increased to 250, minus 250 nanoteslas, and we can see that the disturbances are clear as well. It means that the impact was noticed over most of the globe. But it looks that SWPC is sleeping again, because they didn't increase the KP index, and it's still at 2 points when I'm recording this movie. Maybe they didn't notice that we have a geomagnetic storm, and the overall power grew almost to 50 gigawatts here at around 18 UTC. Over the southern hemisphere it was stronger, and it was probably above 50 gigawatts. On the ACE density graph, we can see that the frontal density wave was quite dense. In some points it reached almost 24 particles per cubic centimeter. Let's look how the impact looked like on the new SWFM magnetosphere monitors. Notice that the initial impact was almost immediately followed by a plasma discharge. Notice that while we are being hit by waves of particles one after another, the density of particles in the current rings and radiation belts is dropping here. The blue color means that there is less particles than in the surrounding. This can be explained only by a disconnection which is continuously sucking out the particles from the current rings. The impact on the ionospheric potential was pretty violent.